Obviously, for the first check to do in simulation, you check for your maximum operating load. Now, I went to a SOLIDWORKS World, and one guy's presentation talked about how children, he just mentioned it really briefly, the maximum operating load for adults isn't the same as the one for children. The children one is higher, because children do things with your products that you never would expect them to do, right? So keep that in mind when you're setting these maximum operating loads. Also misuse, right? The Bose headphones, the common thread in when they broke is people falling asleep on airplanes with them. Now maybe the Bose engineers thought of it, maybe they didn't, but falling asleep with them, I bet the engineers thought they were misuse. Maybe the customers thought that's a perfectly rational use for a Bose sound canceling headphone, right? So think about that when you're doing your first checks for max load. The plastic probably failed in fatigue. It probably didn't fail. If you look at the Bose threads, it didn't fail the first time. It failed, about a month in every single time. So again, you're going with fatigue. And the last thing I would suggest for this first check is check at the end of your material life, right? Sure, when the product comes out of the package, it may stand up, it may hold these loads, but a lot of plastics degrade with the sun. This is a graph of max stress a plastic can take given months in the sun. Now, there's some types that hold on really well, there's some types that break down. This is actually a type of plastic specifically designed to break down in the sun. It's supposed to be biodegradable. It's supposed to wear away. But a lot of times, this PCL plastic, you know what they use it for? They use it for rapid prototyping machines. So I found one thread where a guy had made these light fixtures for his bike in a rapid prototyper out of PCL. Now, if you didn't know about this curve, if they break in 4 months, I wonder if you'll be mad, right? Think about the load at the end of its material life, at the end of your plastic material life. Al's a big biker. This is a pretty cool design, right, Al?
It is, actually. It's interesting.
Yeah, I mean, for night biking, the guy made it on the rapid prototyping machine, but he made it out of PCL, so I'm just hoping he used the right type. All right? If he had bought that at Brookstone, or maybe a high-end bike store, and it broke within 3 to 4 months, he'd probably be pretty mad. Again, this is just an example. People don't usually make production parts out of PCL, but this is a very dramatic graph, which is why I wanted to show it. And people are using it. All right. So what's the big problem that people always tell us about when you're simulating consumer-type products, things with a lot of C2 continuity? It's always the mesh. 80% of simulating models is getting the mesh right. So I won't go through this. This is, again, a model we downloaded. I won't go through the whole thing. You can call us in for a demonstration for that. But just talking about the mesh, there's 2 types of meshes in SOLIDWORKS. One is the standard mesher. This has been there forever. And if you zoom into the headphones and you do a standard mesh, it kind of looks like this, right? Okay. Some of you savvy simulation users will notice there's a little checkbox that says curvature-based mesh. And why would you use that? Well, look what's going on. The main difference is right around these endpoints where these teardrops or these Nike symbols end. Okay? Look at how the curvature-based mesher automatically makes the mesh finer around those points. Not so here, but it does make them finer. Those points are going to be stress concentrations. In a standard mesher, you'd have to do a lot of local mesh controls, maybe, or maybe to make the mesh finer. Curvature-based mesher does a really good job of adapting. So if you're doing a lot of C2 continuity stuff, your parts look more like dolphins than that lizard or crystals. Check out the curvature-based mesher. They actually made it the, I don't know if they talked about doing this or they did it, but a couple years ago they made it the standard mesh without telling people, and then this last year they kind of made it back to you have a choice. Do you remember that, Al? If they made it like in 2011, 2010, they made it the standard mesher?
I don't remember that, but this is a great example of curvature-based meshing versus standard meshing.
Yeah, I'm actually kind of very happy how the meshes came out. That's curvature-based mesher. It's actually a very handy mesher. The idea is you mesh and forget. It's taking a lot of the thinking out of the meshing. Whereas a human would have to go through and wonder if these sharp points would be good enough in a standard mesh. It takes a little bit of the burden off you. So I like it. If I'm doing weird shapes like this, this headphone, I'm probably going to use the curvature-based mesher most of the time. Again, real simple option in simulation. We won't belabor it, but that's the biggest hurdle people have to meshing these shapes in simulation. All right. Let's keep going here. All right, that's the first check. Fatigue, a max load under weird conditions.